In this video, we're going to discuss section 9.1, which is about linear systems and graphing, and specifically we're going to talk about what it means for something to be a solution to a linear system. So let's just get the general idea. A system of linear equations is a set of at least two linear equations, and the solution to a system of equation is the point, or really possibly points, where two lines intersect. This will be a solution to both of the linear equations. So let's look at exactly what I'm saying. So here's a system. Negative x plus y equals negative 6. And 8x plus y equals 75. In this point here, 9, 3, is a solution to that linear equation, or linear system, I should say. So let's look at why that is. If I take that point, where 9 is my x and 3 is my y, and plug it in, it should solve, or should be a solution to both of these equations. So if I plug that point in, that'd be negative, and x is 9, plus y is 3, equals negative 6. And that's simply taking that point and plugging it into this first equation. And if I check that, I'll get negative 6 equals negative 6. Which is true. So now let's take it, and it should satisfy this equation also. 8 times 9 plus 3 should give me 75. 72 plus 3 should be 75, and 75 equals 75. So indeed, that's why 9, 3 is a solution to that linear system. So for example, let's determine if each of the following is a solution to the system of linear equations. So we need to take this point for x and y and plug it into the first equation and into the second equation and make sure they're both true. So let's start first. I'm going to use a different color. Let's plug it into the first equation. X is negative 1, so negative 1 minus 3 times y is 2. Should give me negative 7. Negative 1 minus 3 times 2 is 6, so negative 1 minus 6 should be negative 7, and indeed negative 7 equals negative 7. That one's good, so the first equation is true. So let's plug those into the second one, and I'm going to switch colors again. 6 times x is negative 1. Plus 2 times y is 2, and we're saying the result should be negative 2. So multiplying 6 times negative 1 is negative 6. 2 times 2 is 4. That should give me negative 2. And negative 2 equals negative 2, which is true. So both of those are true, and indeed this is a solution. The point negative 1, 2 is the solution to those systems of equation. Let's try B now and see if again that's true. So I'm going to plug both these points into the first equation first. 4 times negative 2 plus 2 times negative 3 should give me 5. Negative 8. And then 2 times negative 3 is negative 6. Should give me 5. Negative 14 equals 5. Well, that is not true. And because of that, this is actually not a solution. We can stop there. We don't even need to plug it into the second one. The point needs to make both equations true. So let's look at what it actually means for something to be a solution, or how we can find them. The solution is going to be the point where the graphs intersect. So we want to graph each of these and look for where they intersect. So we're going to start first by graphing 3x minus 2y equals negative 12. Yeah, I'm going to do that with intercepts. I'm going to do this by trying x equals 0 and y equals 0. and get some points. So if I try x equals 0, 3 times 0 minus 2y equals negative 12. So negative 2y equals negative 12. Dividing by negative 2, we get y equals 6. So 0, comma 6 is a point on the graph. If we try y equals 0, 3x minus 2 times 0 equals negative 12. So 3x equals negative 12. X equals negative 4. Negative 4, 0 is a point on this graph. Now if you notice, to get from negative 4 to 6, you're technically, I could pick another middle point. Let's pick one here. And what you'll notice is you're rising 3 and running 2. Rising 3 and running 2. You want to make several points because remember, you're looking for where these two graphs intersect. So rise 3, run 2. I'm going to add another point here. I could even go down 3. Down 3, 1, 2, 3, run 2. So I get multiple points. And I connect them. That is the graph of 3x minus 2y equals negative 12. Now what I'm going to do is I'm going to erase all this because I still need to graph my 2x plus y equals negative 1. So hang on with me for just a second while I erase this. Alright, so now let's look at graphing 2x plus y equals negative 1. Well, if I look at that, I would say that is very close or very easy to put in a slope-intercept form. You could do the intercept thing again, but let's put this in slope-intercept form by making it y equals. So I'm going to minus 2x over here. And I get y equals negative 2x minus 1. And I'm going to graph this in blue. So if I graph that, the y-intercept is negative 1. And negative 2 is the slope. That's telling me to go down 2 and run 1. Down 2 and run 1. Down 2 and run 1. Well, if you notice, I'm going away from our graph that we had previously done. I want to work towards that. So I could go up 2 and left 1. Up 2 and left 1, and now I can see where those two graphs, here's my graph of y equals negative 2x minus 1, where those two graphs intersect is this point here. Its coordinates would be the solution. The coordinates of that point are negative 2, positive 3, and that is the solution. Negative 2, positive 3 is the solution to that linear system. Okay, so one more example, and again, you can graph these however you want. But if I was to look at these, both of these are slope-intercept form. So these should be pretty easy to graph because they're already in slope-intercept form. So let's do this one, 3x plus 6. So that tells me the y-intercept is 6, and I want to rise 3 and run 1. Rise 3 and run 1. And if I was to do that again, I'd be going off the page. So let's do some going the other direction. If I go down 3, I'd need to go left 1. Down 3, left 1. Down 3, left 1. And the reason, again, that I'm putting a bunch of points for this is, remember, I'm looking for the point where the two graphs intersect. So here's my y equals 3x plus 6. Okay, let's move on. I'm going to do this one now in blue. The y-intercept there is negative 2. 1 over 3 for the slope. So rise 1, run 3. Rise 1, run 3. And what you'll see there, the problem is, again, I'm running away from that other line that I want to find the intersection with. So I'm actually going to go down 1 and left 3. And now I can see where those two graphs intersect at. They intersect at this point right here. The coordinates of that point would be x is -3 and y is also -3. And again, that is the coordinates of the point where the two graphs intersect. So it's up to you. You can graph any way that you choose, but what you're really looking for is the point where the two graphs intersect at.